Here we look at a particular type of trail and circuit. We call them Eulerian or Euler. Remember we looked at Euler's formula before, that German mathematician who did a lot of work on graphs? Well, these are Euler trails and circuits. And the way I like to think of it is E for Euler and E for edges. So Euler always deals with edges. Now in the last topic where we were looking at a traversable graph, we said first of all it had to be connected and traversable. So if it's connected and traversable, then we can start talking about Euler, because Euler deals with all of the edges. Now a trail starts and finishes at a different spot, but it will use every edge. And the easiest way to identify that is when we look at our graph and it has two odd vertices and the rest even. So if you remember back to looking at traversable, there were two different rules. Well, one of the rules will give you an Euler trail, and that's when you're dealing with two odd and the rest even. And when you've got all even vertices, you end up with an Euler circuit. Okay, so that is going to be a really handy hint to be able to help us to identify our Euler trails and circuits. Have a look at some of the examples there. A postman wants to deliver mail without travelling along any streets more than once. Obviously, it would be more cost effective if he doesn't have to go back over streets that he's already been down. Or what about the next one? A visitor to a tourist park wants to minimise the distance they walk and see all the attractions by not having to retrace their steps at any stage. Again, getting value for money by not having to go to places that you've already been and along streets that you've already been. So this example wants us to determine whether the graph has an Euler trail or circuit or nothing at all. And if it does have a trail or circuit, explain why. So let's start again by working out the degree on every edge, because we know it's tied to that. So the degree here is 2, 2, 2 and 2. It is a connected graph. It is traversable because it has all even vertices. And we now know that anything that has all even vertices has an Euler circuit. So here, because it's a circuit, we can start at any vertice, and so I'm going to go like that, up that way, and then back that way. And obviously I start and finish at the same point because that's what a circuit does. Okay, what about the next one? We'll start the same way, working out the degrees. So we have 2, 2, 2, 3 and 3. So you can see there that we have two odds and the rest even. Now our graph is connected, which is what we want it to be.